some are not. We'll just have to read each question carefully. But we're going to be dealing with a deck of cards, a standard deck of cards that has how many? 52. And we all have seen a deck of cards, and if we haven't, we need to get familiar with a deck of cards. We need to understand that there are 4 suits, right? Diamonds, hearts, spades, and clubs. And if there's 52 cards altogether divided into 4 suits, then each suit must have 13, right? 52 divided by 4. So when it says, well, the first question's kind of generic. It says, how many 5-card hands are possible? Well, how many cards are there in the deck? 52. How many do we want to pick at a time? 5. Does the order that we pick them matter? No. So that would be 52C5. So there will be 52 C5 total hands, different hands in the deck. Okay, that's pretty easy. It's pretty obvious. All right, now look at the next one. What is the probability of being dealt a hand with all diamonds? Okay, now wait a minute. All diamonds. How many diamonds are in the deck? 13. How many diamonds do we want? 5. So we're going to have 13 C5. That would be all diamonds. Think about taking your deck of cards, your 52 cards, and splitting it up into 2 piles. Diamonds, everything else. Wouldn't there be 13 cards in the diamond pile? And you're picking all 5 out of that one pile. You want all diamonds. So every card you pick is coming out of that pile. These don't matter. However, this is a probability question. And what did you learn yesterday about probability? Isn't it always a fraction? And what always goes on the bottom of the probability question? The total number of possibilities? What did we just say the total number of hands is? No. This is the total number of diamond hands. But what's the total number of hands? 52C5. So then I can go to my calculator and I can type that in. Do you remember how to get the C's? Remember, we type, if we're doing the numerator here, we would type 13, and then we go to math, go across to prob and down to NCR. Remember that? We talked about that earlier. And then we put in the 5. So I got 1287 on my top. And then on the bottom, I did the same thing when I put in 52, and I got this. Now you need to reduce that. All right? So you can reduce that like you normally do. You can just look at it and say, okay, I don't know, maybe 3 goes into both of these. I don't know, just start breaking it down. If you've got a calculator, I would do 1287 divided by that number, that big number, and it's going to give you a decimal. If you hit math, don't click anywhere. The very first thing that pops up is frac. If you hit enter, it will turn that, oh, it didn't work. Sometimes it doesn't work. So we have to write down 4.95 times 10 to the negative 4th. That one doesn't convert to a fraction. It is just that decimal. Sometimes it works, sometimes it doesn't. Okay? Now, let's try the next one. That's a little bit confusing. Let's try the next one. What is the probability of being dealt a hand with all face cards? Okay, so here's my deck of cards again. I'm going to split it up into two piles. This is going to be face cards, and this is going to be everything else. Okay? All right, what are face cards? They have faces on them, right? They're the people cards. So what are those? We have kings, queens, and jacks. Right? So how many are there altogether? There's a queen, a king, and a jack for diamonds, clubs, hearts, and spades. So how many would that be? 12. So I've got 12 face cards in this pile and everything else over here. I am picking all face cards. So here's my 12, and I'm going to pick 5 cards out of that pile, right? So what's that going to look like in terms of my setup? 52C. Well, 52C5 is going in the bottom because it's a probability question. That's the total. 12C. But on the top is going to be 12C5 because why 12 again? Where did that 12 come from? How many face cards there are, and I'm going to pick 5 of them. All these problems are 5 cards. So then I go to my calculator. This is the last one I'm going to type in because it just takes so much time to type in. Remember how to do it. We press 12, math, click across the prob, and it's 5. So that's 792. You can put it all in at once. You absolutely can put it all in at once. You sure can. You put it in and divide. So you get 52 C5. And, oh, that's the same number I had before. And decimally, I got 3.047 times 10 to the negative 4th. I don't know if that one's going to change that. No, that one doesn't change either. So that would be the decimal representation of that big ugly fraction there. Okay? Let's look at the next question and see if you can help me figure this one out. What's the next question? How many, or excuse me, what is the probability of an all red hand? Okay, now wait a minute. Think about, here's your deck of cards, split it into 2 piles. Red, not red. How many cards are in the red pile? 26. And you want 5 of them? So your numerator would be 26C5. Now, where did the 26 come from, kids? 26 red cards. Why 5? Because the problem says pick a 5-card hand. Okay? Now, what's your denominator? 52C5. Kids, listen. Anytime you're picking a 5-card hand, your denominator is going to be 52C5. If you were picking a 7-card hand, it would be 52C7. Right? Okay. Oh, look at E, getting a little more complicated. What's the probability of being dealt a hand with 3 jacks and 2 kings? 3 jacks and 2 kings. All right, now, let's take our deck of cards and let's split it up into 3 piles this time. A pile of jacks, a pile of kings, and everything else. How many cards are in my jack pile? No, in the total pile of jacks, how many are there? 4 jacks. How many of those do I want to pick? 3. So I would say 4C3. Because there are 4 jacks total, and I want to pick 3 of them. Now, how many kings are there total to pick from? 4. And how many of those do I want? 2. So I'm going to take 4C3, that's my jacks, times 4C2, that is my kings. Now, this is another probability question, though, so I still have to divide by 52C5. Okay, so somebody explain to me, what's this for? That's how many jacks there are all together in my pile. And what's this 3? That's how many I am picking. What's this for? That's how many kings there are in the pile, and I am picking 2 of them. What's this 52? Total number of cards in the deck, and I am picking a total of 5. My denominator is always the totals. And in a 5-card hand problem, it's always going to be 52C5. All right, F. What is the probability of being dealt a hand with no face cards? Okay, now wait a minute. No face cards. A minute ago, we split our deck into 2 piles. Face cards, no face cards. How many cards were in the face? How many face cards did we say we had? 12? So how many other cards are there? 40. And we want to pick from that other pile, right? We don't want any face cards. So take the 12 face cards out, and now you've got 40 to pick from. So what's that going to look like?
42.
Good. 40C5 divided by 52C5. Bingo. You're done. Perfect. Beautiful. What is the probability of being dealt a 5-card hand and having all of the aces? Okay, now let's talk about that for a minute. First of all, this is not possible. Yeah, you can't have 4 things and pick 5, right? So we'll never have a situation like this. That's just not possible. So let's stop a minute and think about this. You're going to have a 5-card hand, and you want 4 aces, right? What's the other card? Something else. So 4 aces and a non-ace. Any non-ace card, right? Give me anything. All right. How many aces are there total? In the whole deck, how many aces are there? 4. And you want to pick all 4 of them. Right? How many other cards are there in the deck total? Total other cards in the deck, not aces. Take the aces out. How many other cards are there? 48. And you want to pick how many of those? 1. That's 48C1. So this is 4 total aces, and you want all 4 of them. You're picking all 4. This is 48 other cards, and you're picking 1. And once again, it's a probability question, so that's going to be divided by 52C5. I'm going to say it again. If it's a 5-card hand, your denominator is going to be 52C5 every time. What's the probability of being dealt with a 5-card hand and having 2 10s, 2 jacks, 1 queen? Oh, good grief. I want 2 10s, 2 jacks, and 1 queen. All right, so what are you thinking? Start with the 10s. I want 2 10s. What's that going to look like? I want 2 10s. How many 10s are in the deck? 4. And how many do I want? 2. So that would be 4C2. This is how many choices you have, and this is how many you are picking. Does that make sense to you? Now we want 2 jacks. Okay, what's that going to look like? Same thing, isn't it? Aren't there 4 jacks and we're picking 2 of them? Now we want 1 queen. 4C1. All over 52C5. And again, when you go to type this in on your calculator, you can type it in as individual pieces, so you can find this number and this number and this number and multiply them together, or you can do it all together. Your calculator will do 4C2 times 4C2 times 4C1. It will do all that in one step if you want to do it that way. I want a 5-card hand, no aces, no queens, no 5s. All right, now let's think about this for a second. I want to deal you a hand, but I don't want you to have any aces, any queens, or any 5s. Okay? So before I start dealing, I'm going to take those cards out. I'm going to set them over here to the side. How many cards am I going to take out? 12. I'm going to take out 4 aces, 4 queens, and 4 5s, right? So now I'm ready to deal you your hand. How many cards do I have left? 40. How many of those 40 am I going to give you? 5. So what's my numerator? 40C5. And my denominator is, of course, 52C5. Now, does everybody understand where the 40 came from? We have a whole deck of cards. There are 4 aces, 4 queens, and 4 5s. I took those out. That's 12 cards I took out. That leaves me with 40. And I'm going to give you 5. Okay? Now, there's a little bit of room down at the bottom. Let's squeeze in one more problem. See if you can do this. Erica?
So, since it's like a decimal, does that mean that there's only like a 2%?
What did the decimal turn out to be?
0.2532.
0.2532? No, that would be a 25.32% chance. Remember, the decimal point is 2 places. So that's actually a pretty high probability in card terms. Remember that other one we got was 23 times 10 to the negative 4. That's 0.000423. That is 0.04%. That's virtually nothing. I mean, that's very low. This means you have about a 1 in 4 chance. That's about a 1 in 4 chance of having that happen. All right, let's try one more. Let's try 5-card hand again. What's the probability of exactly 2 diamonds? Okay, you know what the denominator is going to be, right? The denominator is going to be 52C5. Okay. Now let's think about this. Exactly 2 diamonds. So Julian is saying 13C2 is going to get me started. Now, that's not it though. We're not done. But can somebody explain why 13, why 2? Where's that coming from? Hannah? There are 13 diamonds, right, and you want 2 of them. Okay? So I have dealt you 2 diamonds. Now, is this problem over? No, because how many cards are you supposed to have? 5. How many do you have right now? 2. Where are the other 3 going to come from? Don't say anywhere. They're not coming from anywhere. They can't be diamonds. So the other 3 are coming from what? Clubs, spades, or hearts. How many total clubs, spades, hearts are there? 39. So the other 3 cards are coming from those 39. So 39C3. Now, every time we do this problem, kids will get this part, but they'll forget these 3 because they're not mentioned in the problem. It doesn't say anything about those 3, right? It just says 2 diamonds. But you have to pay attention to the fact you need 5 cards. Okay, 2 of them are diamonds, that's great, but there have to be 3 other cards, right? And they can't be diamonds. So does that make sense to everybody? If you didn't put this in, you would only be getting 2 cards. That's not enough. Is everybody okay? All right, so at the beginning of the period I said there are several ways to do probability. Yesterday, your probabilities came from a chart, right? You had table of values and what was it, candy, M&Ms or something? Yeah. And so you just figured that out. Now today, we started with this set of card problems. And when we do card problems, we're going to set them up as every single one of the problems we did today was a combination problem, right? That's how we're going to do our card problems. Now, turn to page 60, we have a different kind of probability. We have what's called Venn diagram probability. Now, you've all seen a Venn diagram before, right? So you know, in that circle that I have there at the top, I have 30 students in the class. And so that is why at the top of the box, there's a 30. Okay? That means there's 30 kids in this box. Now, how many like M&Ms? That's question A. 17. Perfect. Why are there 17 kids who like M&Ms? Because the whole M circle, has 17 kids in it. Perfect. How many like only M&Ms? That's the 11. You see the difference between those 2 questions? Yeah. How many like M&Ms and Twix? 6. Those are the football in the middle. These are the people that are part of both circles. They like both. How many like M&Ms or Twix?
30. 15.
What'd you say, Zach? How'd you get 26? Exactly. If you are in a circle, doesn't that mean you like M&Ms or Twix? So there's 26 people in those circles. There are 26 people in here. All right, now wait a minute. Somebody says, but there's supposed to be 30. Well, explain that to me. 4 people are out here. They're in the box, but they're not in a circle because for whatever reason, they don't like candy. Yeah, I know. Right? Weirdos is right. Okay? All right. E. How many like only M&Ms or only Twix? Did you say 20? Because it's these guys or these guys, right? How many like neither candy? You already answered that question 4. All right. Now, that's easy. Yep, the Venn diagram is filled in for you. All right, let's look at question 4. Now we have another Venn diagram, but you have to fill in the numbers. All right, so let's see what's going on here. We have 28 students in the class, and we have jazz music, and we have country music. Now, read the question carefully. Everybody in the class, JQ, everybody in the class likes one kind of music or the other. And everybody likes something. We don't have this. Everybody likes something. It says that in the problem. Now, here's the deal. It says 18 like jazz and 14 like country. That's too many kids, right?
Yeah.
So what does that mean? Some like both. Okay? So we've got 18 and 14. How many is that? 32. But there's only 28 kids in the class. So how many kids like both? 4. There are 4 kids that are duplicated. Think of it like this. If I had all 28 kids in the room and I say, raise your hand if you like jazz, 18 hands go up. And then I say, okay, raise your hand if you like country, and 14 hands go up. What does that mean? 32 hands went up. There's only 28 kids in the room, so 4 people voted twice. Now, 18 students like jazz. That means your entire jazz circle is 18. But 4 of them have already been counted. So how many go here? 14. The whole jazz circle is 18. Remember when I said raise your hand and 18 hands went up? 4 kids raised their hand twice. These 14 only raised it once. Does that make sense to you? Total of 18? Now, 14 students like country. So what's this? 10. All right, now we're ready to answer the questions. Oh, shoot, there are no questions.
Yeah.
Oh, no, there is a question. How many students like only jazz? It's written right there. It says draw a Venn diagram. How many students like only jazz? The answer would be 14. Oh my. Now number 5. Another Venn diagram. But oh, we got some weird notation going on. So let's talk about what's happening here. Basically, it's the same kind of scenario. We just don't have words now, we have symbols. So we have an A ball and a B ball. All right, this means the probability of A is 0.6. This means, obviously, the probability of B, and it is 0.5. And this means the probability of A and B is 0.2. Okay, so that's what the notation means. Little P stand for probability. Now, look right here. This says the probability of being in the A ball and the B ball is 0.2. So look at your Venn diagram. Aren't you going to put the 0.2 right here? Aren't those the people that are in A and B? So that would be like saying, I'll just make up an example. You've got, this is the circle of girls, and this is the circle of people who do sports. So what would that be? 20% of the people are girls who do sports. It's just a percentage instead of an actual number. Now, if the whole A circle was 0.6, but 0.2 of them are already here. What's this? 0.4. And the whole V circle was 0.5, so this must be 0.3. Now, before we go one step farther, think about what we did a minute ago. What's 0.4, 0.2, and 0.3? Add it up. That's only 0.9. So there are 0.1 outside the circles. Why? Because in a probability situation, what do you have to total? You got to total 100%, right?
So wouldn't that mean they're boys who don't play sports?
That's right, that's exactly, in my example, that's exactly what they would be, Moses. They would be boys who don't play sports. All right, so now we're going to answer the questions. All right, this means, what's the probability? I'm not going to write probability. Everybody understands that's what the P means, right?
Yeah.
What's the probability of A and not B? That's what this means. This means A and not B. So what that means is you are in the A circle, but you are not in the B circle. So look at your picture. What is the number that is in the A ball, but not in the B ball? 0.4.
Does that little dash thing mean
Not. All right, so then C is, what's that one say?
not A?
Not A and B. So you are not in the A ball, but you are in the B ball, which would be 0.3. What does this say?
Not A.
It says not A and not B. So that means you're in neither ball. That's 0.1. All right, let's get through the next one and then we'll call it a day, okay? So here's the next one. All right, so now we got C and D. All right, it says the probability of C is 0.75, probability of D is 0.4, and the probability of C and D, this means C and D, is 0.35. All right, so where are you putting the 0.35? You're putting it right here in the middle. That's both. That's the people that are both. Everybody good? All right, now, if the probability of the whole C ball is 0.75, what's this going to be right here? 0.40. Right, I'm going to go ahead and put 0.40, but it's 0.4, yep? Is that okay with everybody? The whole ball has to be 75. Now, the whole D ball is 0.4. So what's this? 0.05. Yep. Everybody good? Now, what do those add up to? 80. Which tells me what? There's 0.2 out here. Because remember, in a probability question, it has to add up to 100. Right? Total has got to be 100 every time. Okay, so here are our questions. We're the V's coming from. I think those are supposed to be D's. Sorry about that, kids. I think those are supposed to be D's. I don't have any B's going on. All right, here we go. Let's answer the questions. Somebody tell me what this says.
C and not D.
C and not D. If you fill in your Venn diagram, these are easy. C and not D would be 0.4. Is everybody okay with that? What does this say? Not C and D. All right, what would not C and D be? 0.05. What does this say? Not C and not D, so that's our leftover 0.2. Everybody got it?
So is there going to be a sign for both? Like for the 0.35? Is there like a sign?
Yeah, it was in the given right here. This says C and D.
Oh, so that's
Yeah. All right, if you still have anything to get made up from retreat or whatever else in the last, I don't know, since I gave you the last deadline, you need to get that turned in.